Hello everyone, welcome to another video. Today we're going to do chapter 4. This is the last section with the word problems. You can see that I have a table here that sort of outlines the general trend of questions. But the most important thing is that when we talk about word problems, you see, we are going to form equations using some of the concept of formula covered here below. And then once you form the equation, you're just solving the unknowns. So you got to think of it that way. Okay, so I think most of the teachers who have done this in class, so I'm going to go through only one, the most important one. You can see that in this case, the points fall on the same line. We call this collinear. This is how it looks like. These 3 points fall on the same line. So how do you form equations using this concept? Whenever you see like same line or collinear, basically you can see that AB's gradient is the same as AC's gradient. It's the same, right? It's the same line, right? Similarly, BC is also the same gradient, and AC is the same gradient. So there are many gradients that are the same. So you can see that AB, AC, BC all got the same gradient, and from there we can form the equation there. Okay, so this is the one I want to focus. If you haven't got this on your notes, please write this down. Okay, so we're going to start doing the questions, okay, all the word problems. Okay, so you can see that in this case, I have gradient is 3 over 5. That's all I see. That's why I say that immediately is something is equal 3 over 5. And then gradient is equal 3 over 5. So that's why I put the gradient formula down. And then from there, the gradient of what? The gradient of these 2 points. That's why I'm going to use these 2 points, slot into the gradient formula, and I'm going to solve. Finish. Okay, so that's how we form the equation. Now in this case, the question 2 is the same. That's a bit more complicated. You can see that again I got 2 points, blah blah. I got R lies on the y-axis. So again, y-axis is something that you got to take note, because when it's on the y-axis, it's going to be 0, something. That's why I let R equal to 0, y. So y is the unknown. You can see that they say PR equal to QR. So in this case, they gave you the equation already. This is the equation you must form. So QR means, PR means the length. QR also means the length. That's why you can see that I have the 2 square root formula here, line segment formula. And then when it comes to PR, I'm using P, this, and this to form the equation. That's why it is 0 minus 2, y minus 6 over here. So for this one, it's the same. I'm using QR, I'm using this 9,3 and the 0y. So I'm going to put it in. I'm going to square both sides so that there's no more square root. Expand, simplify, end up like this. I solve the simple equation. Now you notice that when I solve y is equal to negative 50 over 6, that's not the answer yet because they asked for coordinate of r. So that's why I must write 0, the y value. Okay. Now next one, well, I was supposed to write down the equation of the straight line, right? So again, straight line means y equal mx plus c, pass through the origin, so it's 0, 0. So origin is another name for the point 0, 0. And then gradient 2. So this is the classic one where I give you gradient, I give you 1 point. So I put y equal mx plus c, the m change to the gradient here, and then I'm going to sub 0, 0, 1 point on the line. C happens to be 0, so it's y equal to 2x plus 0. That's the answer. Okay, so for the next question, they say that find the equation of the straight line that pass through this and with gradient this. So again, it's a classic one. You give you gradient, they give you 1 point. You just put the gradient in, sub the point, find the C, write down the answer. Okay, and then they say this point also pass through the line. So when they say this point pass through the line, that means this P, 3 is going to satisfy the equation of the line here, this one. Okay, so I'm going to sub x equal to P, y equal to 3. So y equal to 3, x equal to P, and again I'm going to solve the simple equation. I find P. So the next one, you can change the question. It should be find K, not the equation of the line. There's a typo here. So I need to find K. So where's K? K is somewhere here. Okay, so I see this line cut something is parallel to this line. So the word parallel is important because When you see parallel, that means this line's gradient is equal to this line's gradient. So let's proceed to find this line's gradient first. Now again, there's a lot of traps here. It cuts y-axis at 2, which means it is 0, 2. Again, it's the cut y-axis, cut x-axis kind of thing. So when it cuts the x-axis, the x is 5, the y is 0. So with these 2 points, I'm going to find the gradient. I solve it into the formula. The gradient is -2/5. Now I'm going to find the gradient of this line. Now be careful, you can only see the gradient when it's y equal mx plus c. 1y equal mx plus c. This is 3y. That's why you see I started here. This is not the gradient, right? This -6k is not the gradient because this needs to be 1y. Be careful. So I'm going to divide by 3 both sides. So here become y. So the 6 divided by 3 becomes -2. And then the 5 divided by 3 become... Oh, wrong. 5/3, sorry. But it doesn't matter because we only want the gradient. So the gradient is -2k, so here. So which means -2/5 is equal to -2k, because the two gradients are supposed to be the same because they are parallel. So I'm from the equation here. I solve the easy maths, the answer found. Okay, so this one, you can see that this is the one we say what, for the same line, right? So which means these 3 lines, these 3 points for the same line, so they're collinear, so it's gradient equal to gradient. So I need to find the gradient of the line. So clearly I need to use the 2 points with all the numbers. They cannot be unknowns, right? It's not how to find. So I use these 2 points, I put into the gradient formula. The gradient is 2/3. Now I need to find k, right? So I need to use k and get it involved into the equation. So one way to do it is I use, in this case, these 2 points. I find the gradient, and this gradient of AB must be equal to this because they're all in the same line. So I use, I think it's AB, put into the formula, equal to 2/3. I solve the equation, I found the answer. Okay, next one. In this case, we have 3 points, and we're supposed to show that they are the vertices of a isosceles triangle. Vertices means they are the points. That means the 3, this ABC form an isosceles triangle. So isosceles triangle means 2 of the sides are the same length. So it's very hard to see like this. So what I do is I actually plotted the thing out. You can see that ABC looks like this. Now the important thing to note that is A and B are actually a horizontal line. You can see that the y coordinate is 2, the y coordinate is 2. So that means this is a horizontal line, which means the length of AB you already know is 1 plus 5. So this AB is 6 without even finding anything. So this length is 6. So what I need to do is I need to find AC and BC. If one of them equal to 6, that's the best. Then I've already shown already. So I find AC. So AC is A and C. I slot into the formula, blah blah blah. Is square root 18. So unfortunately, these 2 are not the same, which means I need to find BC now. So same thing, BC, BC. I'm going to solve it in, and the length is square root 18. So it just happens that these 2 is the same. So since these 2 lengths here and here are the same, ABC is isosceles. Okay, then I'm going to find the area of triangle. So if I look at this triangle, clearly I can do half base times height. So it's half base times the height. Okay, you can see that C is 5, and this point, whatever it is going to be 2. So that means the distance is 3. So this is 3. AB is 6. So it's half base times height. That's why it's half AB times the CX is half, then AB is 6, CX is 3. Right, just times, that's the answer. Okay, so the last question we're going through, this is similar to the question on top, just that we're talking about right angle triangle now. So again, 3 points, I still plot it out because it's not very hard to see. So you can see that again, this is 4, this is 1, so this length here is 3. Similarly, this is 3, 8, right? So this distance must be 5. And then what I'm going to do is I need to what? Show that it's a right angle, right? So right angle triangle naturally brings us to a few things. It's either Tuakaso or Pythagoras theorem. So in this case, it's pretty obvious it's going to be Pythagoras theorem. So this square plus this square is going to be equal to this square. So what I do is I find QR first. So I need to find this length first. So again, Q, R, these 2 points I put in the formula. The answer is square root 34, which also means that QR square is 34, because I square this, I get 34. Okay, then I'm going to do the Pythagoras theorem. I'm going to take this square plus this square, and then see what's the answer. So this is 3 square, 5 square. So you see, 3 square, 5 square equal to 34. And 34 is actually QR square, look. So with this, I write down the Pythagoras theorem, I show already. Okay, so next one, I need to find length of the perpendicular distance from P to QR. So P is here, perpendicular down to QR. So X, this dotted line X is the one I want to find. So this is what we're going to do. We need to form an equation. We need to form an equation that involves X. So this is a bit difficult if you haven't done this before. We're going to use area of triangle equal to area of triangle. So I'm going to find this area of triangle first. So what we can do is we can do half base times height, right? So it's half base times height. So that will be 15 over 2. And then there's another way to find this area of triangle, which is half base times height. And this height is the unknown that we want to get involved. So it's half QR times the X. Okay, QR I already know, see? QR square is 34, right? So it's half 34x equal to this. I'm just going to both sides times 2. The denominator goes away. And I'm going to divide this square root 34 over, and I'm going to answer. So this is some examples of what word problems are like. So again, they can be very easy, they can be very hard. It's about getting used to it and not being scared. Okay, so hope you've done something new. So with this, please start to do the homework. Thank you and bye-bye.